So this whole exercise is related to alkanes and alkenes, and you will find the questions related to these topics. Uh, I'll start with question 33. It has MCQs as well as the structure questions. So in this question, iodine monochloride, which is ICL, it is an interhalogen compound. Molecules of iodine and iodine monochloride have a permanent dipoles. The alkenes react with ICl under suitable condition in a similar way as alkene react with hydrogen chloride. So the reaction is same as alkene react with other substances. Propene react with ICl to form two possible organic products. One of the product is 2-chloro, 1-iodopropane. Complete the mechanism below by adding a curly arrows and the intermediate. So as we know, iodine is less, as we go down the group, electronegativity decreases. So chlorine is more electronegative than iodine. That's why there's a partial negative on chlorine and a partial positive on iodine. So the arrow, the chlorine will take both of these electrons, and the iodine, the partial positive, it will attack on the carbon-carbon double bond, or it will act as an electrophile. What will be the intermediate here? Because in the question, we want iodine to be on the left carbon. So we'll have H here and CH3. And here is iodine attached. The other carbon will have a positive charge. The chlorine, which is having a negative charge and a lone pair, that will attack on the carbon, which is positive, carbon cation, and it will form the final product, which is 2-chloro, 1-iodopropane. Is it clear? The next we have classify the type and the mechanism in A1. So what is the type and what is the mechanism of this reaction? So what type is there? So it is electrophilic addition reaction. So it is electrophilic addition reaction. So alkene reactions are electrophilic addition reactions. Draw the structure of other possible organic product of the reaction. So what is another possible product is there? Maybe the iodine is attached on the right hand side and the chlorine is attached with the left hand side. So what might be the product? So the product will be C, H, H. It will be Cl here and it will be CH3, H and I. That's another product which is possible because like iodine might be attached with the carbon on the left or may attach with the carbon on the right hand side. But that will be a minor product. What is the why it will be a minor product? Because when it was forming a carbon cation in this way, this was a carbon cation and iodine attached here. This carbon cation is surrounded by two alkyl groups. So if I draw a carbon cation here for the formation of this new product, so in that case, the carbon cation will be surrounded by one alkyl group. So one alkyl group, it is less stable than a carbon cation. So this will be a product, but that will be a minor product. The major product will be when iodine is attached to the carbon on the left-hand side. Methane react with ICl under suitable condition to form many products. Two of these products are iodomethane and hydrogen chloride. The reaction between a methane and a chlorine is similar as a methane with the reaction between methane and ICl is similar to that a reaction between methane and a chlorine. Suggest the essential condition. So what is the essential condition when methane was reacting with halogen? So we need ultraviolet light or UV radiation. So same thing, if we want ICl to react with a methane, we will also have the same condition. We can mention a temperature to be around 300. That is also acceptable, but don't say heat or don't say only radiation. Specify like temperature 300 or mention a UV radiation or ultraviolet radiation. The mechanism for the reaction between methane and ICl involve three stages. One of these is a third and the final stage called the termination. Describe the mechanism of the reaction to form iodomethane and hydrogen chloride. So whenever you see a static question, it means they will check even the grammatical mistake. The sentence should not, it should be grammatically correct, and it should be a structured answer rather than you just mention or so a lot of things will be there. So in your answer include the type and the mechanism. Then we have to say like, so the type here, it's a free radical and the mechanism is a substitution. So free radical and the substitution reaction happen or occur. So the type of reaction, it's a free radical substitution. Alkanes undergo substitution reaction. So it's a free radical substitution. Type of bond fission occur, like what kind of bond breaking happen? It will always be a homolytic bond breaking in this type of reactions. Then the name and the equation for the first stage. So first stage, it produces a free radical like we have to include all of these points when we are writing the answer. So name and equation, name and then the equation for a first stage. So for a first stage, what we call that as the initiation step. And in initiation, what will happen? The ICl, because it produces a free radical, so it will produce a iodine free radical and a chlorine free radical. Both free radicals will be produced in the first stage. Then what happened in the second stage? The second stage is called propagation. And the product which we want, what substitution we want it to form methane with ICl. Suitable condition, many more products are there. So we have a iodine free radical is also there, and we also have a chlorine free radical. So we can complete this equation with both. Like one of them, if we have a methane, which is CH4, and an iodine free radical attack on this, so what it will form? It will form a methyl radical and it will form hydrogen iodide. And then, but in the question, if you see, this is possibility, but it is forming iodomethane and hydrogen chloride. So why this in a propagation? Why we don't Yeah, they mentioned in the question. That's why I'm coming to a point that I can write this. But as you can see in the question, they mentioned the mechanism for reaction to form iodomethane and hydrogen chloride. This will not result in a formation of a hydrogen chloride. So then we have, so what I should do, I should first start with a chlorine radical. So when I first react with the, start with the chlorine radical, it will form a methyl radical and it will form hydrogen chloride. That is the first thing. And then the second stage, the methyl radical react with the ICL molecule to form iodomethane and a chlorine radical. So if I start with iodine, why this is not correct? Because in the question, we want a product to be hydrogen chloride, one of the product. If it was an iodine radical, the product will be hydrogen iodide. That's why we are not supposed to include iodine there in the first stage. And in the termination, what will happen? How the reaction will terminate? If a radicals reacted with each other, like example, if iodine radical react with a chlorine radical, it will form ICL. If a methyl radical reacted with a chlorine radical, it will form methyl chloride. And if a iodine radical or a methyl radical react with another methyl radical, what it will form? It will form C2H6. These are, because why we did not include iodine reacting with methyl in this case? Because it will form a iodomethane. We can mention that as well. So this will form CH3I. Yeah, iodine radical can react with iodine radical. It will form iodine molecule. If a chlorine radical react with another chlorine radical, it will form a chlorine molecule. Like lot of possibilities are there, multiple possibilities for this reaction. In question 34, the possible name of this isomer, first we select the longest carbon chain. So this is our longest carbon chain. 4 carbon atoms are there. And the second carbon is having a double bond. So it is butene. So this is butene, but which butene, when we check the heavy groups, like the orientation of the heavy groups, they are on the same side. If identical heavy groups are there, we can say cis or we can also say Z. So we can say cis butene or we can also say Z butene. So B should be the right answer. Next question 35. An electrophile is a species that, what is an electrophile? The term electrophile means they are attracted towards the electron. They are attracted towards the electron rich side, or they have a tendency to accept electron. So which is the right answer? Electrophile can accept a pair of electron to form a covalent bond. That is right. It can donate a pair of electron to form a covalent bond. That will be a nucleophile. Why not D? Look, electrophile is attracted towards the electron rich side. Okay. So when it is attracted towards the electron rich side, it will accept accept electron. That is the definition of electrophile. So what is attracted towards the electron rich side? Either a partial positive can be attracted or either a full positive can be attracted. Both can be attracted towards the electron rich side to form a bond, to accept electron, a pair of electrons. So it's not a rule that electrophile always have a positive charge. Why D is wrong? Because it's not like electrophile should have a positive charge. Electrophile may have a partial positive as well. If you remember the mechanism of alkene reacting with hydrogen, so hydrogen, one of the hydrogen is partial positive, another one is partial negative. So as a result, this partial positive is attracted towards the electron rich side. So this partial positive is electrophile. It's not a positive ion. So electrophile can be a partial positive or it can be a positive ion, positive charge. But it's written, it's always a positive charge. That is wrong. It is either sometime a partial positive or sometime it is a positive charge, like electron deficient. So what is always true? It always tend to accept the pair of electron. So C is totally wrong. C is actually a negative ion. So negative ion attracted towards the positive center. So they are not electrophile, they are nucleophiles. And nucleophile, they should not have a negative charge. They should always have a lone pair. The definition of a nucleophile, which have a tendency to donate a pair of electron, they always have the lone pair, not the charge. This question is about alkenes. Give a molecular formula of this alkene. So 1, 2, 3, 4, 5, 6, 7 carbon atoms are there. And it's an alkene, so the number of hydrogen should be twice. It will be 14. You can also count, like this will have 3 hydrogens, this will have 2 hydrogen, this will have 1 hydrogen, this will have 1, 2, 3, 4 are already there. This will have 3 hydrogen, this will have 3 hydrogen, and this will have 2 hydrogen. So when you count them, you will also get 14. Explain why alkenes exhibit geometrical isomer. So why the alkenes show a geometrical isomer? So you have to write a standard explanation for this, that why they have a geometrical isomer. Because of the presence of the carbon-carbon double bond, there is a restriction in the geometry. Due to the presence of the carbon-carbon double bond, the geometry is restricted. As the geometry is restricted, the orientations are restricted. That's why it cannot have other possibilities of the or orientations available. So it will form a geometrical isomer. So one mark for mentioning due to the presence of a carbon-carbon double bond or a pi bond, you can say. So there's a restricted rotation which result in a formation of geometrical isomer. When two different groups are attached as well. Propene react with propene reacts with 3 different reagents. As you can see, reagent 1, it is forming an alcohol. OH and Br is added. So if OH and Br is added, this is actually a bromine water. Aqueous bromine is added. It will add Br and OH. KMNO4 in sulfuric acid. It's a dilute. If it was a concentrated, then the double bond will break and it's an oxidation reaction, but it's a dilute. So as a result, what will form? It will form diol. Yeah, reaction will be oxidation and it will form a diol. The double bond will break and the one OH will be attached here, another will be attached here. And here it is reacting with HBr. So it is a substitution. It is also addition reaction, electrophilic addition. This is electrophilic addition. This is electrophilic addition. So type is electrophilic and the mechanism is addition. Give a reagent needed for reaction 1. Reaction 1, it's OH and Br is added. So we need aqueous bromine. Identify by name or a formula the organic product A formed in reaction 2. So the organic product A, which is formed in the organic product, which is formed in the first reaction, that will the product A, it will be diol. But what diol? So it will be 1, 2, like prop N 1, 2 diol. The double bond will turn into a single bond and the OH will be here. State the color change that would be observed because potassium manganate is purple or pink in color acceptable, and it will decolorize, so it will changes from purple to colorless, or pink to colorless is also acceptable. What will be the product with concentrated? If it was a concentrated, then the double bond will break from here and the oxygen will be attached. So this will form methanol, aldehyde, it will be aldehyde, methanol. And what about this one? This will be C double bonded with O and then CH3. So this is also an aldehyde. So what is this aldehyde? It is ethanol. So it will be a product of methanol and ethanol. The two, both aldehydes will be produced. If it was a concentrated, hot concentrated KMNO4. Give a mechanism for the reaction 3. Use curly arrows. So we want to show addition reaction here. Electrophilic addition reaction we have to show with the curly arrows, and major product. Usually we write for major product until unless they said like for not for major product. So it is propene is there and it is reacting with hydrogen bromide. So hydrogen bromide, it will be HBr. Bromine is more electronegative, hydrogen is less. Bromine will try to take these both electron pairs and the hydrogen will attack. And what intermediate we will have? So it will be CH. This will be any one. Which one is likely? Because if a hydrogen attach here, then this will be the carbon cation, and this carbon cation will be more stable. And according to Markovitch rule as well, like hydrogen attached to a site when number of hydrogen are more. So this is bromine Br with a negative charge, and it will form a bond with this carbon. So the final product will be 2-bromopropane, which will be the major product. 1-bromopropane is also possible, but that will be the minor product. So this will be 2-bromopropane, which is a major product here. Next we have, which of the following alkene exhibit the geometrical isomer? So how we know which one exhibit or show a geometrical isomer? To show a geometrical isomer, the two different groups should be attached to a carbon, which are having a double bond. So if you check this one, so this is CH, like C double bonded with C. Like this is one is hydrogen is attached to that, one is CH3 is attached. This is C, but the two CH3s are attached. So when we break down, two identical groups are attached, so this will not show any geometrical isomer. When we check for B, so C double bonded with C, and this is having two hydrogen. So even I don't have to draw completely because two hydrogens are attached here. So it cannot show a geometrical isomer. What about this as well? So you can clearly see like two hydrogens are there. So when I draw two hydrogen and a carbon-carbon double bond, so identical groups are there. It cannot show geometrical. But what about the last one? The last one, there is a carbon-carbon double bond. One is hydrogen, another is CH3, and one is hydrogen, another CH3. So this will show a geometrical isomer, cis or trans, depending on how they are attached. In question 38, which of the following substances obtained from a fraction distillation of a crude oil has the lowest boiling temperature? So the lowest boiling temperature depends on the number of the carbon atoms. So the refinery gases have the because these are gases at room temperature, so they have the low boiling point. So it means they will have the lowest number of carbon. Because as the number of the carbon increases, the boiling point will also increases. Which of the following statements correctly describes an environmental problem caused by a burning of a hydrocarbon or a fossil fuel? So when we burn fossil fuel, The carbon dioxide is toxic and kill plants? No. The smoke produced reflect the sunlight and leads to a global warming. The smoke produced is not reflecting the light, it is absorbing the light. It is causing a global dimming rather than a global warming. The water produced results in a damaging the increase in a da- the water produced result in a what it do increases the rainfall, and the water produced is actually what will happen. This water which is produced, it is increasing the amount of radiation absorbed by the atmosphere. So as a result, the average temperature increases. So that emission of the water is also leading to a global warming. The carbon dioxide produced absorb the heat radiation from the earth and leads to a global warming. So that's why it matches with option D. And question 40. This question is about the hydrocarbon, the liquefied petroleum gas LPG is a fuel sold as an alternative to petrol. It is a mixture of a liquefied C3 and C4 alkane. Give a reason why alkanes are liquefied. Like why we prefer to have the fuel you mainly in a liquid state. So it is easy to store something in a liquid or a solid state rather than a gaseous state. Easy to transport the fuel in a liquid or a solid state. Like example, it's easy to transfer coal or petrol as compared to a gas. So the main reason is for liquefying is it will make it easy for a storage and a transportation, both. Alkanes, usually the lower alkanes, which are like C till C5, they are like C4, they are gases at room temperature. But we, under a high pressure, we convert them into liquid. There are two C4 alkanes. Draw a skeletal formula of each and a name also skeletal formula. So in a skeletal formula, 1, 2, 3, 4, that is butane, and this is 2-methyl propane. So this is 2-methyl propane, and this is butane. Here we have to draw a name. Complete the following sentence. Compound with the same molecular formula but different structural formula. What we call them as structural isomers. Propane, which is C3H8, react with a chlorine in a substitution reaction. The mechanism of this described in 3 stages. Give an initiation step. So what happened in an initiation step? A chlorine radical is produced from a chlorine molecule. Cl2 will produce 2 chlorine radicals, and the condition we need UV. 2 propagation stages for this reaction. So C3H8 reacted with a chlorine radical to form C3H7 plus HCl, and then the propyl radical react with another chlorine molecule to form C3H7Cl plus chlorine radical. That's a propagation. Termination, we just have to react all the radicals. Chlorine react with another chlorine, or a propyl radical react with a chlorine radical, or a propyl radical react with another propyl radical. We have to complete a product. I did not write the final product. I just wrote the combination which will react. C3H7. So this will result in Cl2. This will result in C3H7Cl. And this will result in C6NH14. So the evidence of a free radical substitution reaction is the formation of C6H14. Because other products are possible, but this is only possible if the mechanism is a free radical substitution reaction. Myrcene C10H16 is a naturally occurring compound which is used in a perfumes. Name the functional group which are present. So name the functional group which is present. As you can clearly see that the carbon-carbon double bond is there. So which functional group is present here? The functional group present is alkene. What color change we'll observe if a bromine is dissolved in organic solvent is added? So there's a difference between aqueous bromine and the organic bromine. If it is aqueous bromine, then we'll say from orange to colorless. But in this case, it should be brown to colorless. It is acceptable to say orange or orange yellow. That's fine. The final color will be, it will be colorless. So starting from orange to colorless or brown to colorless. Classify the type and the mechanism of this reaction. The color of a bromine, actual color in an aqueous medium, in organic medium, it is brown. That is red or brown. That's the right color. But it is, they accept the orange. Orange or yellow is in aqueous bromine. So what is the type of the reaction? The type of reaction is, because the bromine is added to alkene, so it is, the type is electrophilic. And what kind of mechanism it happen? It is addition. So it's an electrophilic addition. In an experiment, 1.36 gram of this substance is having a molar mass of 136, reacted with 0.72 dm cube of a hydrogen in the presence of a nickel as a catalyst. Use in information, draw the structural formula. So first, how many moles we'll get? 1.36 divided by 136. How many moles we'll get? We'll get 0.01. 1.36 divided by 136. What's the answer? 0.01, yeah. So 0.01 moles we'll get. And for the moles of the hydrogen, so this is these are the moles of the compound. How many moles of hydrogen? That is volume in dm cube divided by 24, because standard experimental standard conditions is done. So 0.72 divided by 24, how many moles are there? 0.03. So what is the ratio between them? If we take the simplest ratio, 0.01, we divide. So the ratio is 1:3. It means 1 mole is reacting with 3 moles of hydrogen. We want to draw the structure of a product. If this thing is reacting with the 3 moles of the hydrogen, so the double bond will break, like this double bond will break, this double bond will break, and this double bond will break. And what we'll have? We'll have a single bond here. And this will have C2, this will be C3, CH, and this will be CH2 and CH. Like 6 hydrogens will be added, one with like 2 for each double bond. So as a result, we will have a final product, which is an alkane. So using a calculation, we worked out how many moles of hydrogen are reacting. Hence, draw the structural formula of the product. So same thing we'll redraw, but without a double bond. Then one group of a molecule related to 2-methyl butene. Draw the structural 2-methyl undergoes an addition polymer in the similar way. Draw the structural formula of the repeat unit of the polymer. So we want to draw the repeat unit. So we just break the double bond. But in a repeat unit, you're not supposed to write like N is optional here. Because we just want to draw the repeat units. If they say draw the structure of a polymer, then we draw, put a bracket and write N. If the question was draw a polymer of this, like the question can be Draw the polymer of this. In that case, what we will do, we'll draw the same structure, put a bracket, and then we have to write N. But if they say repeat units, we are not supposed to. We can draw 1 unit, we can draw 2. Better when they ask for repeat unit, at least draw 2, but it is fine, you draw 1 as well. In question 41, which of these statements about carbon-carbon double bond is false? Like, which is not the right statement for a carbon-carbon double bond? The two ends of a molecule cannot rotate relative to each other about the axis of a double bond. So this statement is true because when the carbon-carbon double bond are there, like molecule orientations are fixed. One is in, another one will be out. It cannot be rotated or they cannot change the orientation. So they will remain fixed at that their orientation. So this there are twice as strong as a carbon-carbon single bond. That is wrong. Like if you compare the bond energies, it's not like if a carbon-carbon single bond is 100, the carbon-carbon double bond is 200. No, it's not the same number. So this is a false statement. They have a higher electron density in a single bond. That is true because a carbon-carbon double bond has 4 electrons as compared to a single bond which is having 2 electrons. They consist of a sigma and a pi bond. That is also true. The next is what is the correct name of the compound? So below, we select the longest carbon chain. So 1, 2, 3, 4, 5. When we count from a nearest double bond because so 1 will be 2, 3, 4, 5, 6. 1, 2, 3, sorry, 4, 5, not 6. This will be 4 and this 5. So which position we have a carbon-carbon double bond? So second position we have a double bond, so it will be pentuene. So pentuene is correct. And when we compare the groups, the mass of the group, which is having a greater mass, bromine mass is 80. Here the carbon is like this carbon is C2H5. So this will not be 80. So the heavy groups are attached on the same side. So this should be Z. So this will be Z because of this. And second position, third position, bromine are attached. So 2, 3 dibromo and pentuene. So D will be the right answer. Because when we compare the heavy groups, we compare the masses. Like here, this is CH3, the mass will be 15, but bromine is 80. When we compare C2H5, the mass will be 29 here and the mass will be 80. So the heavy groups are attached on the same side. That's why it will be Z. And second and third position, we have a bromine. And the second position, we have a double bond. So it is Z23 dibromo pen 2 ene. Is it clear? Discussion?